Alright everybody, here's Mr. Longo with a video on rotations. Excuse the tone of the microphone. I do not have my good microphone with me, so you guys are going to have to deal with the computer microphone, so I apologize in advance if it sounds a little muffled or distant. But what we're going to cover in this video is different types of rotations. Now, rotations is probably one of the more challenging of the transformations you guys are going to be working with. So this video is going to go into some detail. So it will be a little longer than the last couple, but I think you'll get the idea. So a rotation is going to keep the exact same size and shape, but it's going to point this object in a different direction. So it's going to have a different orientation. Now there's a couple of different directions we can rotate things. We can rotate them clockwise, or we can rotate them counterclockwise. Now, all you really need to think about is one quadrant at a time if we're going to rotate about the origin, okay? Now we have three different types of degrees of rotation that we're going to work with. We have 90 degrees, which is one quadrant if you think about it. So if you're in quadrant 1 here and you're going to rotate 90 degrees, it's only going to be skipping one quadrant, okay? Because if you think, here's a 90-degree angle right there. There's another 90-degree angle, so every quadrant is 90 degrees. Now, we're also going to do 180 degrees, where if you think about 180 degrees, that would be pointing up and then pointing down. So it will be two quadrants away, because if we were, say, out here, 180 degrees from here would be skip one quadrant, skip two quadrants, and now all of a sudden we're totally opposite on the other end. So that's 180 degrees would be two quadrants. And finally, 270 degrees would be three quadrants. Now, something you need to know is 90 degrees clockwise is the same as going 270 degrees counterclockwise, and vice versa. 90 degrees counterclockwise is 270 degrees clockwise. So let's kind of check it out with point A. If I wanted to rotate point A 90 degrees clockwise, first, you need to think about where that's going. So I'm just going to pretend that this is on the second hand of a clock. And now we're going to start rotating. So you're going to rotate 90 degrees clockwise, which is going to put you in this quadrant. Specifically, where is it going to put you? Well, if you think about it, this is currently at 6 to the right, 2 up. But since we're going to be over here, they're going to switch. Now this is actually going to be 2 to the right and 6 down, if we keep this on the same thing. Now, you don't really need those lines there, but you can just kind of look and see what happened there. All we did is basically spin this quadrant 90 degrees clockwise. If we were to do it again, we would be out here. 6 to the left and 2 down. And now if we were to do it this way, we would be 2 to the left and 6 up. But what I want to do really quick is I want to write down those coordinates just for fun. Over here, we have the coordinate 6, 2. Down here, we have 2, -6. Over here, we have -6, -2. And over here, we have 2, -2, 6. Now, right now, I'm not paying attention to the positives and negatives. That's all taken care of by the quadrant, because everything in quadrant 1 is always positive, positive. Everything in quadrant 4 is always positive, negative. Everything in quadrant 3 is always negative, negative. And everything in quadrant 2 is negative, positive. So, I'm not paying attention to the pluses and minuses. I'm paying attention to how every 90 degrees the x and y coordinates switch. So 6, 2 becomes 2, 6. Rotate 90 degrees again, it becomes 6, 2. Rotate again, it becomes 2, 6. And then, of course, back to the original 6, 2. So every 90 degrees, the coordinates x and y are going to switch. And then, of course, the positive and negative part just depends on which quadrant you're in. Okay? So there's two types of rotations we're going to be working with. Rotations around or about the origin, and rotations about a point on the figure. So this would be an example of the origin. So you have this little red triangle, and if you're going to rotate 90 degrees, it's going to be pointing this way. Rotate 90 more, or 180 degrees total, and instead of pointing up, it's now pointing down, and you can just kind of see, or if you go this way, counterclockwise, it just kind of looks like a windmill. This is how you rotate about a point. So everything is going to stay on that one point. It's just that if you wanted to go 90 degrees counterclockwise, instead of pointing up, you're now going to be pointing left. Okay, so that's pretty much how this works. So to see it all in action, let's go practice. I'm going to step you through this one step by step. We're going to rotate this 90 degrees clockwise. So one of the tricks I just showed you above is every 90 degrees your X's and Y's will switch. So an easy way to do rotations about the origin is to list all of your original points. So point A has the coordinates 2, 9. Point B is at 2, 3. And point C is at 5, 8. Now, I'm not going to worry about the positives and negatives yet, but let's think about where we're going. Every one of these points is about to be moved to one quadrant in the clockwise direction. This would be quadrant 4, but everything down here has a positive X value and a negative Y value. But since we're going 90 degrees, our X and Y coordinates are going to switch. So 2, 9 becomes 9, 2. 2, 3 becomes 3, 2. And 5, 8 becomes 8, 5. And now all you have to do is use this positive and negative pattern. Since everything is down here, everything is positive, negative, positive, negative, positive, negative. Now we're just going to go plot those points. A is at 9, negative 2, but he is now a prime. B is at 3, negative 2. He's now B prime. And C is going to be at 8, negative 5, which of course is C prime. If you connect the dots, you can see that this has just been shifted 90 degrees to the right. And you can actually take your paper and start spinning it, and you'll see that they look the exact same. If you take your y-axis and just spin it 90 degrees so your y is actually your x-axis, it's going to look the exact same as that. Okay? Now, one of the other things we talked about up here is if you rotate 90 and then 90 more, 6, 2 is going to go back to being 6, 2. So 180 degrees is not going to switch the X and Y at all, but it will put it in another location. So again, a way to do this is start out by listing your coordinates. D is 7, negative 3. E is at 7, negative 6. And F is at 2, negative 3. So 180 degrees would be 2 quadrants over. Now 180 degrees, it does not matter if you're going clockwise or counterclockwise, because it's going to get you to the same spot. 1, 2, 1, 2. So 180 degrees, it really does not matter which direction you're going. Okay, so 180 degrees from quadrant 4 is going to put us over here in quadrant 2. And again, you do not have to switch, but what you do need to know about quadrant 2 is over here, everything is negative, positive. No switching. 7, 3. 7, 6. 2, 3. Notice I did not put any positives or negatives because that's taken care of by the quadrant. So over here, everything's negative, positive. So we have a negative 7, positive 3. Negative 7, positive 6. Negative 2, positive 3. Go plot them. Here's our D prime. Here's our E prime. here's our F prime. And as you can see, looks like it's just been rotated 180 degrees. So I would like you to pause the video and try this one on your own. Rotate AB 270 degrees counterclockwise, which remember is the same as 90 degrees clockwise. Pause the video, give it a try. As soon as you're ready, click play, and we'll see how you did. And if you got that, you are good to go. So what we did here is we had to rotate 270 degrees counterclockwise, which you could have skipped 3 quadrants going in the counterclockwise direction, or remember, 270 counterclockwise is the same as skipping 1 quadrant in the clockwise direction. Okay, since this is a 90 or a 270 degree rotation, you do switch your coordinates here. And since you're going to be in quadrant 1, both are going to be positive. So you're good to go. Next one is how to rotate about a point. So here's our triangle ABC again. We're going to rotate it 90 degrees clockwise, but this time we're going to do it about point B. So this one is a little bit trickier until you get used to it. Otherwise, it's really not that bad. So think about this. We know B is not going to change, but we do need to figure out A and C, what their new location is going to be. So from B, A is 6 units up. So if we were to rotate up 90 degrees clockwise, that's now going to be pointing right. So A prime is now going to be 6 units to the right of B. So 1, 2, 3, 4, 5, 6 units to the right, we now have our A prime. Okay? Now C is a little bit trickier because it has 2 moves. We need to get from B to C. To do that, we need to go up 5 units and right 3 units. So we have 5 up and 3 right. Okay, so we already know that 90 degrees from up clockwise is going to be to the right. So now this is going to turn into C is going to turn into 5 units to the right. And if you think about 3 units to the right, 90 degrees from there is going to be going down. So this is going to be now 3 down. So to get to C prime, we're going to go 5 units, 1, 2, 3, 4, 5 to the right, and 1, 2, 3 units down. Now if you look at it, it looks like you've just gone and rotated this object 90 degrees clockwise, keeping B as your rotation point. Notice that didn't move, and all we did was rotate it 90 degrees to the right. Okay, so that one is a little bit different. There is nothing you can really do with the whole coordinates because it really depends on where you are. So it's best to just kind of work with this whole left and right thing. So I'm going to let you try this with quadrilateral ABCD, 180 degrees about point C. So think about point C. This one's not going to move. Think about 180 degrees. 180 degrees from up is actually down. 180 degrees from left is right. So think about that while you're graphing. Pause this video, give it a try. Click play when you're ready. So let's see. Since we're starting at C, to get to B, we had to go 1, 2, 3, 4, 5 up. So now that's going to move to 5 down. And that'll give us B prime. So we're going to go down 1, 2, 3, 4, 5. And here's B prime. To get from C to D, we had to go 3 units to the left. So now we're going to make that 3 units to the right to get to D prime. So 1, 2, 3 units to the right. That'll give us D prime. And now, since this is a quadrilateral, it's pretty easy to see where A is going to be. It's going to be at this intersection, but just to show you, by the counting technique, to get from C to A, you would go up 1, 2, 3, 4, 5, and left 3. So we would go up 5 and left 3. So if we were to switch both of those, this would now become 5 down and 3 right. So 5 down, 3 right gets you exactly where we thought it was going to be. And we now have A prime. Okay, so that's how you rotate about a point. I know this was a little bit of a longer video, but like I said, rotating is probably one of the more challenging of all of the transformations you're going to do, so it required a little bit of extra time. Anywho, this is Longo and I'm out. See you, bye.